I would like to talk about a project we started at the beginning of last year in Europe, which has been supported by the European Union. And we are quite a big group, you see about 40 authors. And what we would like to do in this activity is to test time services based on the Galileo signal. The idea of the call was, may we improve the timing coming from the Galileo signal? And as you know, Galileo as GPS is transmitting time. And for the first analysis we did, we saw that users can get UTC from the Galileo signal with an accuracy of 10 nanoseconds. So the service is there. What else is needed? So we started thinking to the users of timing, which are not only the time laboratory, but for example, the energy distribution network. And we saw that what they need is to timestamp the different measurements across the network. And in that case, they need the synchronization of all the network and particularly signals which are resilient to any possible problem as jamming. In another case, we were in contact with people working in speed measurements and fine, and I'm not very popular when I talk about that, but the idea they have is that they need to have some system able to have a low accuracy, but a certification that the time stamping was correct, because they have a lot of contestation that the fine was not due because the machine was not time stamping correctly. And then another issue which happened last January was the problem with the GPS transmission of time, which was wrong. We know this is an issue which was for the first time in 30 years, but there were users that were affected by that, and they asked us how they can be protected to such event. They need redundancy, they need an integrity information. So with that in mind, we started thinking to time as a service. And this is something which comes mostly from the industry. They say, I do not care if you are giving me a radio receiver or a geostationary satellite transmission or whatever. I want to know what time it is, and I want to be sure that my customer will recognize the time stamping I am performing with your system. And so we started the idea to develop a demonstrator, which is actually what you see now. Now it is almost a laboratory. It has been assembled and verified at the beginning of this year, and we are trying to test the service. We start from the idea that we have Galileo or GPS in the sky. We have also the availability of a geostationary satellite, and we have time laboratory. Who knows exactly what time it is, and we have the BIPM, we have the meteorological community. So how can we put together these signals and services in a demonstrator? First, we built a part which is called core infrastructure, which has common services, and then we have a second part which is time service. Each time service is, in the core infrastructure we have the reference time, which is to be transmitted through all channels, and then each time service is composed by a time signal generator. Let's suppose that you take the time and you send that signal on a satellite. Then there is a user terminal receiving that signal, and then there are some measuring facility able to check if the time received at user level is in agreement with what was started as reference. And then we develop some processing, a web page, and the capacity for the users to check what we are doing and to check what their user terminal is doing with respect to the reference time. We do not, assembled this demonstrator at the beginning of this year, and now we are in a phase of test which is called closed loop, where we have the signal generator and the user terminal very close one to the other. So maybe the signal is going to the satellite and it's coming down to the user terminal, but they are just aside. So we can measure with an electronic counter the reference time and the received time. Then after June, we will have a second experimentation phase where the user terminal will be located at user location. That can be another laboratory or users like an energy distribution or a telecom network, and we will test in that operational condition the same services. We have a web page. I invite you to check it. Unfortunately, I did not dare to connect now in real time, so this is a picture taken yesterday. There is a first page with the time, and then you can see there is a login on the top right, where if you are registered, you can connect, you can be registered as a user, and you can check the service that you are interested in. For example, you can choose to see what happens to one service which is broadcasting time on a radio signal, and you can have access to all the measurements. So the service we are developed are, and we are testing, are 9. Some of them are not based on the Galileo signal, and the other are considered as improvement or augmentation of the Galileo signal. The first one is transmitting a code on the radio signal. So users with a simple radio can receive this code and have a clock, for example, like this one, which is synchronized by the radio. We are doing that in Italy since many years. We have this type of code which is transmitted by RAI, the radio broadcasting company, and it is an analogic signal, and we are trying to test if it is possible to do in digital audio or digital video broadcasting. The first experimental results that we had in this period show the difference between the reference time and the time which is received by the users who has a radio, and we see that there were some jumps, there were some issues at the beginning. Now it seems that half millisecond is what can be achieved with this sort of transmission. Another service is based on the internet distribution with NTP. NTP is something which is well known. The idea of this service is not only to send the time on the internet, but also to reverse the role of the users and of the reference, exchanging information to evaluate which is the time at user level. And then the reference is issuing certification and is maintaining in the database a sort of certification of how the user clock was behaving in a certain period. So if the user has any issue, can always ask for this type of certification. The results we have in this case that are related, that are tested on a LAN connection are at the level of millisecond. In the next phase, when using the internet, we expect to have about 10 milliseconds. A third service is based on the distribution on optical fiber. This is based on the white rabbit, mostly on the white rabbit techniques, which is known. We are testing it on long distances. For the moment, the distance is only based on a piece of fiber which is inside the laboratory. In the next phase, we will connect another place which is in Rome, which is at about 800 kilometers from Ingrid, to check the capability of the system, which at the moment is below the nanosecond level. Another service is really sending the signal on a geostationary satellite and then received by a user. The user is passive, so it is not a two-way system, it's just one-way system. And this is of interest for some users we have in Italy, particularly telecom and also the radio and TV broadcast, because they want to have a system completely independent from GNSS to be used in parallel to check one with respect to the other. And in this case, the idea was to have, the goal is to be at the level of 100 nanoseconds, in this case in which the user terminal is very close to the reference time, the geometry is very well in favor, so the results are better. We will see what happens when we move the user terminal far away from England. Another service is the user-receiver calibration. We heard yesterday from Jérôme Delporte the activity in the absolute calibration of the receiver and then the relative calibration of the receiver. We have then other services which are based on the Galileo and GPS signal, trying to improve what is available. In this case, the idea is that the users has a Galileo GPS receiver receiving the data from the satellite. All the measurements in real time are streamed to the reference station, to the reference time, so there is a process of the measurement at user level, and again, all these measurements are stored in the database. They are always available for the users. The users can receive a sort of certification saying that his clock was operating such and such, and the user's clock is also steered. The master station is also sending a steering signal to the users to maintain the clock synchronized with UTC at a low level of, with a high level of accuracy. Another service is similar, but it is for another type of users, let's say for time laboratory that maybe have a time scale or a clock and would like to keep that clock in strict synchronization with UTC, or maybe in real time monitored with respect to reference time. In that case, the users has a GNSS receiver connected to the local time scale or clock. The data are sent to the reference station, and by a PPP analysis, precise point positioning, the difference between the reference time and the user time is evaluated. It is plotted on the web page. The user has a connection with on the web page and can see with half an hour of delay by exchanging hourly file, which was the delay between the user clock and the reference time. And there are also other information on the visibility of the satellites and ionosphere content. And also, if the user is interested, we evaluate the steering correction that the user may apply to keep his time scale synchronized to UTC. This is a type of experimentation for which we are looking for users, so I invite you, if you are interested, if you have any of your clocks connected to a GNSS receiver, to subscribe to our service, send us the data, so we monitor your clock, and particularly we monitor our capacity to produce such service in real time. Another service is related to integrity. We measure the Galileo signal, we evaluate the Galileo clocks and the information coming from the Galileo signal, and we check if everything is working well. For example, we check the difference between the GPS time and Galileo system time, which is called GGTO. This quantity is necessary for the interoperability, and it is available in the navigation message of Galileo in this moment. We also have the mean to measure this quantity. So we have the measurement at user level, what is transmitted in the navigation signal, and so we can check if everything is working as expected. If not, an alarm is raised. For the moment, it is raised on the web page, so it is not a real-time interaction with the users, but this is the first step towards the integrity of the service. We do the same for the clock. When we see that the clock on board has a frequency which is not behaving very well, as there is a jump or any anomalous behavior, we make a list of clocks which are not to be used, and so the users can, in this moment, just a posteriori, but the idea is to discard that clock and to evaluate the positioning and the timing solution without that clock to obtain a better accuracy and better integrity. The last service is again based on GPS Galileo receiver, which sends in real-time data to the master clock, and that receiver is the master receiver of a network, for example, for telecommunication or energy distribution, and the idea is that all the network can be synchronized, scalable, changing the number of receivers inside, and for the moment what has been achieved is a level of accuracy from that user receiver with respect to the reference of a few nanoseconds. The goal is to be in tens of nanoseconds, able to certify again that that master clock that can be the reference for an internal network is synchronized with respect to the reference. So when we started, this was November last year, we started putting the different devices in the rack, and we arrived to the laboratory, which was completed in March. In March this year, we had an opening event, and next week we will have a user workshop organized in INRIM in Torino, where we have invited people working in the different fields like finance or telecom or traffic control, speed control, where we plan to have an exchange to see if they can give us feedback on this type of service. And the idea is that they will also have a user terminal to bring home and to take part to our next experimentation part. So these are the addresses on which you can check what we are doing, and we will be happy to have any comment or feedback on this. So thank you very much for your attention.